All right, so far we've seen functions that we can differentiate, but those functions are really basic functions. We don't have any rational functions or functions being multiplied by one another. And we want to think that if we're multiplying f times g, it would just be the derivative of f times the derivative of g, but that's not going to be the case. And we can look at the proofs to see why, but for now we're just going to define these two cases, and then that'll give us some more complicated functions to work with. In the next section, that is by far the most complicated thing that we're going to see, and that should allow us to basically differentiate any other function that we need to, with maybe the exception of a few. Okay, so the derivative of f of x times g of x is going to be f prime times g plus g prime times f. And we can write that as the derivative of the first times the second plus the derivative of the second times the first, just so that we can kind of memorize it a little bit. Let's look at an example. So we're asked here to find the derivative of f of x, well, m of x is equal to cosine squared x. And so normally we wouldn't think of this as two functions being multiplied, but we can write this as cosine x times cosine x. And so our first function we could call f, the second one we'll call g, and they're both the same. So f prime is negative sine x, g prime is negative sine x. And so if we just follow our formula for the product rule, we're going to have m prime of x is equal to f prime g plus g prime f, and that's going to be negative sine x times cosine x plus negative sine x times cosine x. So really we could write that as negative 2 sine x cosine x if we want. Next, find dy dx. Now remember the derivative of y with respect to x, that's what dy dx is. And so here we're going to be given y is equal to the square root of x times secant x. And so again, we want to try to break this up into two different functions. So our derivative, remember that we can write the square root of x as x to the 1/2. So we're going to write this as x to the 1/2, square root of x, times the derivative of secant x, plus the derivative of x to the 1/2 times secant x. Now it doesn't matter which we do first, if it's f prime g plus g prime f, or if we write it as g prime f plus f prime g. So you can see that in this one I'm doing the derivative of the second function first, and it doesn't really matter which order we put them in. So the derivative of secant x is going to be secant x tangent x. And the derivative of x to the 1/2, we're going to bring down that exponent, so we're going to have 1/2 x to the negative 1/2. And we can rearrange these just a little bit, so we end up with the square root of x secant x tan x plus secant x over 2 square root x. So now if we're given a function of the form f of x divided by g of x, where g can't be 0, its derivative is going to be given by this thing right here. Okay, so we have the derivative of f over g is g times f prime minus f times g prime divided by g of x squared. And so let's go ahead and take a look at an example. And before we do that, we can think of this thing as the derivative of the top over the bottom is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared, where the top is obviously the numerator and the bottom is going to be the denominator. All right. So find the derivative of x squared plus 1 over x squared minus 4. And so we're going to have the bottom, x squared minus 4, times the derivative of the top, which is 2x, minus the top, x squared plus 1, times the derivative of the bottom, which is 2x, all over the bottom squared. And so we can simplify the top a little bit. It's going to be 2x cubed minus 8x minus 2x cubed plus 2x. And we can take it just a little bit further. We end up with a negative 10x on top. So this is about as far as we can go. Doesn't look too bad. All right, so find the derivative of cosecant x. So this one's, again, going to look a little bit strange because it doesn't really look like a rational function. But remember that we can rewrite cosecant x as 1 over sine x. And so if we apply the quotient rule, we have sine x times the derivative of 1 minus 1 times the derivative of sine x divided by sine squared x. So that whole first term is 0 minus cosine x divided by sine squared. And we can break this up to be cosine x over sine x times 1 over sine x. And we do need a negative there. So this is going to become negative cotangent x, cosecant x, and usually we write this derivative as negative cosecant x, cotangent x. Okay, find the derivative of f of x is equal to x cubed minus 2x plus 1 over the square root of x. Now keep in mind that we can use the product rule or the quotient rule because that x to the negative 1/2. And so we don't really have an idea of which one's going to be easier or which one's going to be harder. So we'll just go ahead and try to pick one to use. Alright, so we have two ways to handle this, either with the quotient rule or with the product rule. So let's just try to randomly pick one. We end up here with the product rule. And so we're going to rewrite this thing now so that we have x to the negative 1/2 instead of divided by the square root of x. So the derivative, we're going to use the product rule. And when we simplify that a few times, we're going to have different denominators. And so we could stop here if we wanted to. It looks totally fine. But if we're solving some kind of an application, we might want to find a common denominator, which would be 2x to the 3/2. When we do that, the numerators actually get kind of simple. And so our end product here is going to be 5x cubed minus 2x minus 1 divided by 2x to the 3/2.